everybody who is watching this fantastic video. My name is Olenjolai. I'm very happy. Simply just call me Sir Olenjolai. I'm very happy to have you today. Whether you're a national, international viewer, you're warmly welcome into Tanzania online or advanced secondary schools in square bracket LAW&SUPERPOSITION. So I'm a Tanzanian, and also I come from Tanzania. And actually, I would like to dedicate these programs to all the Tanzanians who are in advanced level or who are expecting to be in advanced level within a short time. Okay, so before I go into today's lecture or today's sessions 12, I would like to welcome you into one of our schools. That's called Tanzania Online Advanced Secondary School in square bracket OLENJOLAIM. Simultaneously, because I'm teaching also advanced mathematics, basic applied mathematics, basic mathematics, basic engineering mathematics, basic scientific mathematics, basic higher engineering mathematics, and higher scientific mathematics. In all of those aspects of mathematics, we are also solving simultaneous equations. So simultaneously, I would like to welcome you into one of our YouTube channels. We have 6 YouTube channels that we are providing training. Tanzania Online A-Level Secondary School in square bracket OLENJOLAIM. Well enough. You can say, okay, now thank you for Olenjolai. Thank you, Olenjolai, for welcoming me. I appreciate your appreciations and your acceptance. Now you have some questions in your mind. First of all, what the vision that we have in Tanzania Online Advanced Secondary Schools in square bracket OLENJOLAIM? Well, according to the book of Proverbs chapter 29 verse 18, it says that where there is no vision, people perish. Similarly, if we don't have visions in Tanzania Online Advanced Secondary Schools in square bracket OLENJOLAIM, actually we are going to perish. So I would like to take this opportunity and welcome you into this fantastic moment. And I would like just also to, yes, it means I would like just to declare the visions that you have in your mind. These are the visions. We have an assignment from God to teach, train, incubate, mentor, encourage, lead, and motivate some group of advanced secondary students who will be ready to extract knowledge and wisdom from the formal and informal classroom instructions and combine it with the knowledge and wisdom that we are going to extract from the Word of God that written in the Holy Bible in order to solve real life problems. So actually the visions has 4 parts. First of all, extract knowledge and wisdom from the formal and informal classroom instructions in science and the advanced mathematics. Again, the second part, we are going to teach you to extract knowledge and wisdom from the Word of God written in the Holy Bible. And the third part, we are going to teach you on how we can combine these 2 knowledge and wisdoms in order to achieve the first achievement, which is to solve real life problems. We have different scales of real life problems. I want just to tell you that myself, I'm a product of what I'm telling you. When I heard for the first time more than 5 years ago, it was completely impossible. But after practice and working consistently, then I realized that now I'm enjoying the fruits of that 2 combinations of the knowledge and wisdom. So I'm going to be with you, and possibly also you're asking yourself so many questions. How can you master advanced physics for the Form 5? How can you master advanced chemistry for the Form 5? How can you master advanced mathematics for the Form 5? How can you master basic applied mathematics for the Form 5? And then how can you master advanced physics, advanced chemistry, advanced mathematics, and basic applied mathematics for the Form 6? So you've been wandering around, how can you master? How can you understand? What should you do in order for you to be competent in these 8 subjects of the 2 classes? So the answer of those questions and even other questions that I didn't mention, you will find it in Tanzania Online Advanced Secondary Schools in square bracket OLENJOLAIM. So well, here we have so many departments, but one of them is advanced physics, and the subject of the day is advanced physics. So we are teaching in this department, teaching 2 subjects: advanced physics for the Form 5, advanced physics for the Form 6. And the subject is advanced physics, okay? And the main topic is electrostatic. It is the first main topic according to the syllabus. The first main topic is mechanics. The second main topic is heat. The third main topic is wave and vibrations. And the fourth is electrostatics. So here we have S. Wow. So again, we would like to ask you that for you to be registered and get notifications or online informations once, because we are going to add more than 500 videos in our YouTube channels that you can access them free of charge. So we ask you that to click this button to sign in by using your email, subscribe, and then the bell will appear. Click it once, so click here once, and click this bell once, and then so you see 3 options, all, personalized, and none. So choose all, so you'll get notifications once we add a new video, because every day we are going to add at least 1 video in our YouTube channels that called TANZANIA Online A-Level Second School in square bracket OLENJOLAIM. So stay connected, join me please. Okay, I will give you some other announcement when we'll be proceeding with our today's session. So we have the session 12. This is the continuations of the session 11, session 11, session 10, session even session 9, and etc. Yes, session 10, yeah, session 10, etc. No, session 10, yeah. So no. So this is just the continuations of 40 of session 11. So problem solving on electric field strengths. That's the today's lecture. So let me do the quick review of 40 of lecture of session 11. So in session 11, basically we say that we have a terminology called in physics electric field. So join me, take your exercise book, take your scientific calculator, take your scientific calculator, take your pen, take your ruler, and then serve a focus and follow along. So electric field. So we define some electric field. It is actually the region where the electric field is working, where the electric field is experienced. So that is. Then we discussed about the properties of properties of electric field. Okay, of electric field. So we discussed about properties of electric field. Then she said that he discussed about the elections of the electric fields. That positive means that electric field from positive charge. Okay, positive charge, or from negative Q. So we discussed. Or also from what? Positive Q when you place it with negative Q. Or positive and positive, or negative and negative. We discussed about that. And then she defined about the electric field. Okay, electric field strengths. Okay, electric field strengths, and this denotations is in. So simply say that the electric field strength, first of all, it's a vector quantity. So this we can get by taking the electrostatic force of attraction, so repulsions between the two charges, and that's divided by the point charge Q naught. So simply with this formula, we can say that we have Q, then we have QK, then we have R squared, if you do remember, right? So Q, K, R squared, where K is what? This is it's a constant which contains permittivity of the free space. So that the free, but because this is actual vector quantity, so we have something like this. So if you do remember that we said those electric field strengths, this K representing what? 1/4 pi permittivity of free space. Then we have what? Then we have R squared, and here we have Q. So simply, this is Q over 4 pi permittivity of free space, R squared, as what? As a scalar quantity. So this is a scalar quantity. But as vector quantity, we can also express it that way. So remember homework 11, which was example 22. I asked you to use dimension to reduce it. Reduce the dimension of what? Dimensions of electric field strength. Also, I ask you that use the concepts of what of dimension to reduce it as a unit of what? Of electric field strength. Okay? So to do that, let me just to give you the response. Okay? The response. So answer, or yes, answer. We have part A. So it means dimensions of electric field strength. When you do this, the correct response or correct formula. Okay, it will be what? Mass times length, then times what? Period, Then the result times electric current as scalar quantity power -1. So that is the dimensions of what? Of electric field strength. The SI unit simply being the SI unit of electric field strength is Newton per coulomb. Why Newton per coulomb? Because it is force over quantity of charge. So that's all about what we've discussed in lecture 11. I love lecture 11 because I taught you consistently in 2 hours. So it's a lecture of the 2 hours. And actually that I taught you in a very different way compared to how I used to teach other students physically for the 5 years. So there are kinds of improvements, so much improvements that God is doing in this program. So ladies and gentlemen, let me right now teach you about example 23. So example 23, so let us solve example 23 together, and then we'll go for other examples. The point charge of that, point charge of 2 exponent -7 of positive 2 exponent -7 coulomb is situated 40 millimeter from the point charge is situated 40 millimeter from the point charge from another point charge from another point charge of -5 exponent -7 coulomb. Then full stop. In vacuum, not in water, not in any other mediums, not in paper, not in nickel. Okay? So what is the field strength at the midway between the 2 charges? So what, question now, what is the field strength? What is the field strength at the midway between the 2 point charge? Between 2 charges. Between 2 charges. Okay, that's the question. Very interesting question. Right? So the point charge of positive 2 exponent -7 coulomb is situated 40 millimeter from another point charge of -5 exponent -7 coulombs in vacuum. What the field strength at the midway between 2 charges? Okay, so this is the question. Well, ladies and gentlemen, you are allowed to pause the video and then try to solve this problem on a piece of paper on your own, and then come back to check the corrections or check the way that I solved, so you may enjoy the beauty of advanced physics. Do you enjoy the beauty of advanced physics? Tell me in the comment section. So the point charge, so the first step, we say that sketch the problem. Sketch the problem. So to sketch the problem, we have 2 point charge, right? And then so you have a distance between them. So the first one, it is positive 2 exponent -7 coulomb. Then the distance between the centers, because remember the distance is measured between the centers of the point charge. This is 40 millimeter, right? So this other point charge is what? -5. Just a quantity of charge of -5 is for -7 what? Coulomb. Where the midway? The midway, actually it's a center here. So it is midway, you'll find that if you just label like this, we find that this is 20 millimeter, and here it is what? Also it is 20 millimeter. 20 millimeter, 20 millimeter. So this is figure 12. So to find, we have to understand whether that means that, remember that remember that we are looking for the field strengths at this point. So we have to go for the second step. Remember that this contents is for the Form 5 or Pre-Form 5 or Form 6 or Pre-Form 6 or Class 13s of the following combinations in Tanzania: PCM, PCM, PMC, Endorsing, and PCB. So P stands for Advanced in Physics. So the second step, we say that let the pointing charge at the midway to be what? To be 1 or to be Q naught. Can't be Q naught. So if we sketch right now, okay, so this is the midpoint. So here we have Q naught. So remember that we have this distance as what? 20 millimeter, and also we have the distance that is 20 millimeter. Here we have 2 exponent -7 Coulomb positive, and this is -5, so -7 Coulomb, right? So here you have what? The Q naught. So after sketching, okay, after having this sketch, we can now enjoy the beauty of advanced physics, and especially electrostatics. Remember to subscribe, please. If you forgot, please click the software buttons of subscribe for you to get notification. So the second step, we have read that once, okay? So the third step, right? So you say that you have to recall the general formula of finding what? Electric field strength. Find electric field strength. What a formula? Electric field strength, this is equal to electrostatic force over point charge, which experiences electric field strength. So, but from Coulomb's law, electrostatic force is equal to K, for instance, Q times Q naught over R squared. So if that's the case, you say that scalar quantity of electric field strength will be equal to constant K, then Q naught over R squared over Q. So Q naught and Q naught will cancel. So it means the general formula for electric field strength is given as this. And hence we know what is K. K is 9 exponent 9 Q over R. So we have to find the electric field. So let this point be point A, and let this point charge -5 exponent -c to be located at point B, and let this point to be point C. Right? So if that's the case, now we think that the electric field strength experienced at point C due to charge A, so C due to charge A, this will be equal to what? This will be equal to twice, or is equal to 9 exponent 9 times twice is -7. And then we say that avoiding the distance between them is 20 millimeters, so 20 to -3 squared. Right? So if we add, we find that, so this will make it. So when you do that operations, you can use your scientific calculator. Okay? You use your scientific calculator. So the answer is 4.5 exponent 6. 4.5 exponent 6 Newton per Coulomb. So that this is the electric field experienced at point C due to point charge A. Right? Then, ladies and gentlemen, we go for the first step. The first step, you have to find out electric field strength equals C due to B. How do we find it? So we use the formula. You have to keep on enjoying. Okay, so I said that electric field strength at C due to B, this is equal to what? Similarly, this is equal to electrostatic force over Q naught, and this will make K Q. Okay, so let's say Q at point B over R squared. So then this is equal to 9 QB over R squared. So electric field strength at point C due to B, this is equal to 9 QB. QB is what? So QB is 5. You want to include the negative sign. Negative 7 of what? R it is 20. So negative 3 squared. So this one, electric field strength at C due to B, this is equal to what? This is equal to 1.125, 6 Newton per coulomb. But let us check the direction here, okay? So we can check the direction. Check directions of these forces. Okay. So that will be the fifth step. So the fifth step, so let's get short. The direction of what? Electric field strength at point C due to A, and electric field strength at point C due to B. Okay? So we have this 2 point charge, 2 exponent, negative 7 coulomb. This is positive. This is negative 5, negative 7 coulomb. Okay? So this is what? This is Q naught. So this is 20 millimeter, and this is 20 millimeter. So remember, this is positive. So this is point A, this is point C, this is point B. So it means that what will happen? So what is going to happen? So it means that 2 exponent negative 7 coulombs will be pushing 1 exponent negative 7 coulomb, right? Towards right. So this force will be towards this direction. So this force, or the electric field strength at point C due to point A will be towards right. Similarly, this is positive and this is negative. So there's attractions. Here there's a repulsion force. So it means that Q naught will be attracted by negative 5 exponent negative 7 coulomb. So if it will be attracted, then this is the case. So we have electric field strength at point C due to B. So we go for the sixth step. The sixth step, we say that find the resultant, find the resultant electric field. To find the resultant electric field, so it means that AC, so what can we notice? AC due to A, and electric field at C due to B, okay, have same direction. So because this electric field are experienced in the same directions, we say that the resultant electric field, this is equal to what? This will be equal to electric field at point C due to point charge N plus electric field at point C due to point charge B, right? That is. So simply we say that this is equal to 4.5 exponent 6 plus what? 1.125 exponent 6 Newton coulomb. So Newton per coulomb. So then the response will be 4.6, if I'm not mistaken. Excuse me, I think that they made a mistake. This is what? Exponent 6, exponent 7. So exponent 6, this is exponent 7. So electric field exponent C due to B, it is 1.125 exponent 7, isn't it? Exponent 7. Yeah, Newton per Coulomb. Then resultant, that's the resultant. So it means that right now, E resultant is equal to it. Is equal to 1.57 75 exponent what? Exponent 6 Newton per Coulomb. So the questions was asked us what the field strength at the midway. Okay, but was what it was, right? So therefore, the field strength at the midway is 1.575 exponent 6 Newton per Coulomb. So that's the response of that question. Okay? So in case you have any question, don't hesitate to ask in the comment section. You have to keep on enjoying the beauty of advanced physics, and you have to think, how are you going to use these information to solve a real life problem? Maybe some of my students used to ask me, how are you solving real life problems? So, for example, this is the critical real life problems, critical national real life problems from generations after generation. So I'm solving a real life problem. So ladies and gentlemen, that's all about example 23. Right now, let me teach you example 24, and especially to find the point where the what. So find the point of the point where electric field strength is 0. So that the subtitle of this part before we go into the diagram. So it means that finding, just like in case of electric field, finding the point where electric field is not experienced. So electric field is not experienced between the charge or on the left side of one charge or on the right side of 40 of another charge. So it means that you say that there is a point, sometimes electric, just like in case of electric force. I told you this concept, and we did 2 examples, if I'm not mistaken. That was actually giving us the good understanding on how we can find the point where the electrostatic force of attraction or repulsion is not experienced. So here we are dealing with electric field strength, where electric field strength is not experienced, or electric field is not experienced. So let me just put the questions on the blackboard, and then we'll solve it, and I'll be explaining step to step. So a point charge positive Q is placed at 20 millimeter. So example 24. Okay, example 24. So a point charge positive Q is placed at 20 millimeter. Is placed in 20 millimeter. So a point charge positive Q is placed in 20 millimeter from another point charge. From another point charge. From another point charge of what? Of negative 2q in a vacuum. Of negative 2q in a vacuum. In a vacuum, okay? In a vacuum. At what positions? At what position? So the questions. At what position? At what position the electric field is 0? Electric field is 0. So at what position? So a point charge positive q is placed in 20 millimeter from another point charge of negative 2q in a vacuum. At what position the electric field is what? Is 0 or is neutral? So in order to solve this question, we can just, we are going to use trial and error. Trial and error. So, and you have only 3 possibilities. So just add, write concept because this is the conceptual question. So, the first step, sketch the problem. So to sketch the problem, we said that you have a point charge, you have 1 point charge, you have 1 point charge positive q, and another point charge negative 2q, and these 2 point charge are placed to it. Are placed 20 millimeter. 20 millimeter. Okay? And hence in the vacuum. At what positions the electric field is 0? So how many possibilities do you have there? So you have only 3 possibilities. Whether the electric field strength is 0 at this point, at the mid, at a certain point here, or the electric field strength, it can be 0 on the right side or on this side, on the right hand side, or the electric field strength might be 0 on the left hand side. So you have 3 possibilities. So once you'll be given these questions, you have to test it for 3 cases. But how can you distinguish, how can you identify that maybe here the electric field strength between positive q and negative 2q is 0 is when you find that, because actually that we are going to equate, means we are going to equate some equations, and we formulate a quadratic equation, right? So after formulating the quadratic equation, we'll be solving that quadratic equations, which will give us the distance from one reference charge to the point. When you find that the value of the distance after solving quadratic equations give you the positive value and negative value, then start the point where the electric field strength is 0, right? But if you find that you solve the quadratic equations after formulating it, and the value or the roots of the quadratic equations are all negative, then at that point the electric field strength cannot be 0 because we don't have negative, we don't have negative distance, right? So that those are indicators. So we say that we have 3 possibilities. 3 possibilities. These 3 possibilities, the first one, suppose that this is point A, this is point B, this is point C, here it is point D, here it is point E. So electric field strength can be 0 at what? At C. First possibility. Second possibility. Electric field strength can be 0 at what? At D. Then electric field strength can be 0 at what? At E. So those are the 3 possibilities. So you have to test for the first case and test for the second case. So ladies and gentlemen, let us go and just right now the second step. So we say the second step, we say that place the point charge. First of all, okay, place the point charge Q naught or not on the right side of negative 2Q. On the right side of what? Of negative Q. Then we say that let also the distance from what? From positive Q naught to negative Q to be X. So then we have this point charge like this. So here we have what? Okay, we need to have space. So here you have what? You have positive Q, and hence the distance between is 20 millimeter. Then here you have what? Negative 2Q. So we like to put it in somewhere here. So this is our positive Q. Let the distance between these two point charge to be X. Right? So remember that we label this as A, B, C, then this is D. Right? So you can find electric field strength upon D due to point charge negative 2Q, and due to, we can find so electric field strength upon D experienced due to the partials of positive Q. Right? So we say that, yeah, so this is, remember, it is what in first T test. You can do either 2 tests then you end, or you get the right answer, or you can do 3 tests until you get the right answer. So ladies and gentlemen, we said that the third step, you have to record the form of electric field strength, which is 9 exponent 9 times quantity of charge Q over R squared. So simply say that, so this is recorded. So it's electric field at 20D due to point charge located at P. This is equal to what? 9 exponent 9. Then you have Q, which is positive Q. Now, multiply the what? By twice Q. By twice Q. Right? And then this one divided by the distance square, which is X squared. Right? Then so you can determine the directions. This is negative. So Q naught will be attracted on this direction. Right? So if it will be attracted on this direction, so it's either towards what? Towards left. So towards left. Okay, towards left. So simply say that the electric field strength dB, this is 9 exponent 9 times what? 2Q over X squared. This is what? So this, suppose that this is equation 1 and this is equation 2. Okay? So by using equation 1, also you can find electric field strength experienced at D due to what? Okay, so we say that you can find electric field strength when D due to point charge A. So here we have 9 exponent 9. Then you have what? What the charge is Q, right? Don't worry about don't bother yourself about the value of Q, because these two are going to cancel. And here we have what? 20 millimeter plus x squared. Remember also this is x in millimeter. So the unity here, let's express x in millimeter, right? X millimeter. So no need to change 20 millimeter into centimeter or into meter. So let this to be question what? Question 3. So ladies and gentlemen, we say that if, so this will be what? First step. So the first step is a condition. So that if electric field strength is equal to 0 at D, then we say that if you take electric field strength at D due to B, okay, minus electric field strength at D due to M, answer is equal to 0. So that the conditions for electric field strengths are to be equal to 0 at this point D. Right? So if that's the case, we say that this is question 4. So we say that substitute equation what? So substitute equation 2 and 3 in equation 4. So to substitute it, what do we find? So we find that we have 9 exponent 10 exponent 9 times twice q over x squared minus what? 9 exponent 9 times q over 20 plus x is equal to 0. So just bring this on this side. When bring it on the other side, 9 exponent 9 times twice q of what? Over x squared. This will be equal to 9 exponent 9 times q. Remember this is a square, and I have 20 plus x squared. Right? Good. So 9 exponent 9 will cancel, q and q will cancel. So here remains what? 2 over x squared, and there remains 1 over 20 plus x squared. Right? So we say that for nitrogen quadratic equation. So there we have x squared. This is equal to twice 20 plus x squared. So x squared 2, so 20, this is equal to 400. So 40x x squared. Right? And then we say that we have what? So after simplifications, we find x squared because we have 2x squared minus x squared. So this will have x squared plus 80x then plus 800 is equal to 0. So this is question 5. Okay? Okay, so then we say that solve. This will be the fifth step. Solve what? So the fifth step we say that solve for equation 5. No, equation 5, yes. Simultaneous. So the simultaneous equation 5. So you can use your scientific calculator, right? So just use your scientific calculator, and then you find that x squared plus 80x plus 80x plus 800 is equal to 0. So after solving, we find that x is equal to the first value of x is negative 11.75. Negative 11.75 limit. Second value of x2, that will be negative 68.2 millimeter. Negative 68.2 millimeter. So these are the two roots of 40 of the quadratic equations x squared plus 8x plus 800 is equal to 0. Right? So if this is the case, we say that what can we comment? So it means that because say that there is no neutral point. The neutral point, the point where electric field strength is equal to 0. Okay? On the right side of negative 2q. Why? Why? Because the distance, the value of x, the two values of x are negative value. So because they are negative values, that's why. In case you find one is positive, for instance, this is positive, this is negative, then the neutral planes will be existing from 11.5 millimeter from from point charge negative 2p at the fifth step, right? So the sixth step after that, so it means that your first testing has failed. So first test failed. So let us go for the second test. The second test is locate point charge Q naught on the left side of 40 of positive Q. So you have to locate it on this side. Okay? So I'll sketch it like this. So this is positive Q, this is negative 2Q, the distance is 20. So you want to have potential Q naught here, positive, and then we let this distance to be x. Right? So you have to find out the electric field strength. So suppose that this was A, B, C, as usual, C, remember this was D, where we have tested E. Okay? So that's the second testing that you have to do. Okay. So you say that you have located the field strength at point E due to A. So this is equal to K, then Q, positive Q, over X squared. So this is question 1. Yes, you can find not question 1, this is question 6. Yes, you can find that you feel the strength at point E due to potential C. This is equal to what? This is equal to K, then times twice Q over what? Over 20 plus X squared. So this is question 1. Question 7. So remember that we said if, so this is the set state. So this is the sixth state. And this is the seventh state. So the seventh step, we said if electric field is equal to 0 at E, then what? then electric field strength at E due to C will be equal to electric field strength at E due to A. Yes, due to A. So this is similar to say that electric field at C due to C, due to the point charge located at C, minus electric field strength at experienced by point E due to point charge A. Okay, so if that's the case, now we have to we have to equate. So just to equate with this one, say that assume, so we have to assume, okay, that electric field at point E due to point charge D, now due to the point charge A, this one will be equal to electric field strength at point E due to the point charge C. And how are you going to notice that this assumption is not true? In case you solve the quadratic equation, and hence you find the two negative values. The roots of the quadratic equations are the two negative values. So yeah, we are not dealing with complex number equal roots over there. So if we make this assumption, we say that here we have k times q over x squared. Then the other, we have to cross out the multiplication. So once we cross multiplication, so we have 2x squared. This is equal to 1 times x plus 20 squared. So this will make twice x squared, and this we expand x plus 20 times x plus 20. So simply we get 2x is equal to what? Is equal to x squared plus 40x plus 800 or 800. So simply this will make what? When we simplify, we get x squared minus 40x minus 800 is equal to 0. So this will make what equation what? Equation 8. And then so you have to say that we can go to what is the 8th step. 8th step, we said it solve either by using eliminations or substitutions or graphical. Solve what? Solve equation 8. Right? So to solve equation 8, we are going to get two values of x. Good news is one value is positive, which is 48.28 millimeter. 48.28 millimeter. Very far, right? And the other one, x2, it's negative 8.28. It is nearby. Negative 8.28 millimeter. So we don't have a negative distance always. We have only positive distance. So here we find that, this is the distance, because remember we let this x to be what? The distance from what? From the point where electric field strength is 0 to the positive q. Right? So therefore we conclude that the point is that one from this one and this one from the negative 2q. From negative 2q. So we have to come back. So here it means you can replace this 48.28, and here also we can replace this 48.28. So therefore, because the questions ask us the point, so the point is what? 44.28 millimeter from what? From negative q. From negative q. And what? So 48.28 plus what? Plus 20. That makes what? 68. Makes what? 68.28 millimeter from what? From negative 2. So that's the response for this problem. Right? If you have any question or you got stuck anywhere, Please don't hesitate to ask your questions in the comment section. Okay, example 20. 22, 23, 24. This is homework. Homework what? 12. So the question states that a point charge positive select U is located 10 millimeters away from negative 4Q in a vacuum. So the question asks you that at what position selective field strength is 0? At what point or position where the electric field strength is 0. So make sure to do this homework and submit your homework in the comment section. Remember to subscribe, please, for notifications. So submit homework. You submit homework 12 on at comment section. Comment sections of this video. Okay, so this is the end of today's session 12, which is very interesting. I taught you two examples, very interesting examples for you, and I left you one example for you just to test your understanding. This is the end of today's session. I thank God who have been with me and who have created me in His own image and likeness, and I thank God who have built the teaching industry in my mind. So I would like just to ask you once again, in case you feel from your heart that you want to offer our God your free willing thanksgiving through these programs, then you may send through 0759745331, and your free willing thanksgivings or anything of the offering that you are going to send on that phone or that telephone number will be used effectively just to pay for the running cost of this program, so that if more than 500 videos of advanced secondary education will be in air for the present and future generations. So make sure to do it. In case you want, you do it for God. Don't do it for me or for somebody to post or to praise you. Remember also to subscribe, and remember also to watch this video several times as well as you can. I invite you to join me in the next session, which will be session 3, where I'll be teaching now on how you can find the electric field strengths when the point charge are located in a three-dimensional figure, so in a triangle or in a rectangle or in square, etc. So that's the expectation. So you have to make sure that you join me. Invite your friends, invite your classmates to enjoy the beauty of advanced physics for the rest of your life. So stay tuned, stay connected, go through this session several times as well as you can, so that these concepts has to click and remain in your mind for the rest of your life. So may God bless you. I love you so much. I used to pray always for all my online Tanzania, my online advanced secondary students. And also I ask you also to pray for me, so that we may accomplish God's vision in our life. Please use the comment sections to ask a question. Subscribe, please. Share these contents with your classmates. Join me in the next lecture, in the next session 13. And may God bless you. This is Olenjolai from beautiful country Tanzania. And this is our national flag. And this is the place, or this is the country where God lives. So keep on enjoying the kingdoms of heaven in advanced physics. And see you then.